Welcome back. In the last video, we kind of roughly outlined the workflow we want to use for our Gradio demo. We want to input some images of food. That's going to be our inputs. Then we want to use a function such as predict to map our images of food to our outputs. And we discussed briefly that we'd like our outputs to be a tuple of food class labels, which will be, in fact, a dictionary of the class name mapping to a prediction probability, so we can get some nice output like this. And we also want the prediction time so that we can continue to evaluate one of our criterias, which is a fast model. So that's what's going to give us this prediction time here. So how'd you go? Did you try out the challenge I issued in the last video of filling in the blanks here? I trust you gave it a shot, but if not, let's now do it together. I just realized I had a typo there. So let's see how we can start this timer. We'll go start time equals timer. Now we want to transform the image for use with FNetB2. What do we have to do here? We've got some sort of input image here. So let's now reassign it to FNetB2 transforms. That's going to, of course, format the image or transform the image in a way that is compatible with the FNetB2 model. We've seen this before. Now, the one step that might be a bit tricky is we have to unsqueeze it, because typically an image is going to come in without a batch dimension. So unsqueeze equals add batch dimension on 0th index. So we're adding a batch dimension there and transforming the image. Now we're going to put the model into evaluation mode. We've seen this one before. So fnetb2.eval, and then we're going to turn on inference mode to make a prediction or make inference. And so now let's pass transformed image through the model and turn the prediction logits into probabilities. Beautiful. Now, how do we do that? So we can do that by going fnetb2 image, or we can go predprobs equals torch.softmax, pass our image through fnetb2, and we want to call torch.softmax on the first dimension of the outputs of here. That's going to create a predprobs output. So we now want to turn this tensor of predprobs, so one prediction probability per class output, we want to turn that into a dictionary so that we can map, say, steak as a prediction probability of 61% or 0.61. Sushi has a probability of 0.30. Pizza has a probability of 0.09. So we want to turn that into some form of dictionary so that Gradio can manipulate it into something that looks pretty. So we've got our class names list. We might need to use this. Class names. So how about we go class names I, we'll do a little list comprehension here. Class names I float predprobs, turn them into a float, predprobs 0 I for I in range len class names. And then there's a dictionary there. Beautiful. So what this is doing is it's creating a dictionary using a list comprehension, and the inputs to the dictionary are going to be class names, this list here, indexing on the relative index on predprobs for the range in length class names. So for each predprobs sample that comes out, we want to index the relative one to pizza. So pizza is going to get some sort of value. Steak's going to get some sort of value. Same with sushi. So now we can calculate we're going to see the output of this in a second. So don't worry if it's a little bit confusing. We can step through that. Calculate the pred time. So we need to end the timer here. Pred time equals round timer. We can just do it like end time equals timer. We could do it like that. End time minus start time, and we're going to round that. Let's round it to 4 decimal places. We've been using that fairly often. And then I think that's all we need. Let's see if this works, hey? We want our ideal output to be a dictionary of class names and the prediction time, how long it took. So how can we test this out? Well, let's get a random image from the test data set and pass it through our predict function. So from pill, let's import image so we can open it. And we want to get a list of all test image file paths. We've done this before, but we'll do it again, hey? Test data paths equals list path. We'll do a little bit of practice. Test directory. We'll get a glob for anything that matches this pattern, star/star.jpg. And then if we have a look at test data paths, let's get the first one. Beautiful. And then what can we do? Let's randomly select one of these images. So randomly select a test image path. So we go random image path equals random.sample. That's why we imported random up here. Random.sample. Let's sample the test data paths. And then we're going to go K. Number of samples we want 1. We want the 0th index because this is going to give us the path itself. Beautiful. Now, what should we do here? Well, we want to open the target image so we can pass it through our predict function. So this is just strictly mapping an opened image to a prediction. We can use Gradio's components to open an image here. So this is what's going to be our input in our interface class, but we're going to see this later on. So Gradio provides a lot of functionality for things like opening a file or opening an image or a whole bunch others here, as you can see. So let's keep going forward. For us to try out our function, we're going to use pills image.open to open our random image path. Random image path. And then let's go, predict. Let's have a look at the image actually. There we go, we've got sushi. Now, of course, this is going to be random every time. So let's write down some info. I want predicting on image at path, random image path. So we know where the image is coming from. Then we'll go a new line and let's go predict on the target image and print out the outputs. So let's try our function, predict, or we'll save predict pred time equals predict image equals image. So this is our predict function. And it's not pred, it's predict. There we go. And let's print out the predict and the pred time. So if everything works, we should get a well-formatted prediction based on a given image. There we go, beautiful. What do we get? Predicting on image at path, data, pizza, steak, sushi, 20%, test, steak. So it's an image of steak. Our prediction, there's our dictionary there. That's exactly what we wanted. That's what this line is generating. So it's looping through each one of the class names, pizza, steak, sushi, and then assigning the appropriate pred prob to that class name. So it looks like our model got this right because its highest prediction probability is on steak. And the prediction time was 0.13 seconds. So let's try that again. And why don't we try that? So that's steak. Steak was the highest. Wonderful. Steak again. Steak a highest. Can we get another one that's not steak? Sushi. There we go. Oh, and sushi was the highest. Awesome. So our model is doing quite well here, but we already know that. So there's pizza. Pizza's got the highest. Beautiful. So now we have a function to map our images of food to an ML model to the outputs. That's exactly what we want. So one more thing we're going to do before we turn this into a Gradio interface is to create some examples. Now, why would we do this? So this is what we want to replicate. We've got a function to go from image to this now. The examples we're going to do is so that if someone didn't have an image ready to upload, such as I've got one pre-made because this is a machine learning cooking show. The examples is going to showcase how you can use the app. So that's what we're going to create in the next video. I'll see you there.